Hi to all. In this video, we are going to see about manufacturing techniques of machines. Okay, motor manufacturing process flow. Okay, the basic manufacturing process for electrical AC and DC motors are shown in this section. Within each process, there are significant variables, each depending upon the manufacturing equipment's size and variety of the parts, efficiency requirements, and economics. Each one of these process variables following text. AC motors manufacturing process flow illustrates the basic AC motor manufacturing process flow. The first step is producing laminations. These laminations are separated into rotors and stators. Okay, lamination is nothing but silicon steel stamplings. We are making a small, uh, thin slices. Okay, so the stator lamination shown in figure. Then stacked onto core and copper. Aluminum wire is wound into the core, producing a wound stator core. And outer housing of some type of is produced that the wrapped around the wound core, making a wound stator assembly. Okay, these are things we are going to see in this thing. The rotor laminations is in also stacked and the aluminum die cast into a rotor casting shown in figure. Okay, a shaft in this produced and this assembled in the rotor, making it rotor assembly shown in figure. The rotor assembly is sent to motor assembly. Two ends, okay, two ends frames produced and sent to motor assembly at the final operation. Okay, so now we see the completed motor. The motor is then tested, painted, and packed for shipment. Okay, there are two types. One is AC motor manufacturing process, another is stator laminations. DC motor manufacturing process. Here the the basic DC motor manufacturing process is illustrated in figure. Like AC motors, the first step is producing laminations for the pole pieces and armature. Okay, the pole piece laminations is stacked with several other components into a pole piece assembly. The pole piece on DC motors may be a solid steel. Okay, shown in the figure. Housing is produced, and then when the pole piece are inserted, it becomes frame and field assembly. This frame and field assembly is sent to the motor assembly. Rotor laminations, rotor casting, rotor assembly. Brushes with other components are assembled into the brush assembly. Okay, and this is then assembled on the frame and field assembly. The armature lamination is stacked into a core, which is then assembled onto a shaft, and copper wire is inserted or wound onto the core. Core is iron part, and copper will be wounded on the core. Okay, and the coils may be connected to the commutator. Commutator is the end of the copper wires as they are wound as in the figure. Okay, or connected after the coils are inserted in the core and shaft assembly as in the. Okay, this is completed armature assembly, which then goes to the final motor assembly. The frame and field assembly, armature assembly, the miscellaneous parts and the assembled into the complete motor. Okay, the motor is then tested, painted, and packed. Okay, end frame manufacturing. The basic purpose of the end frame, sometimes denoted as end bell, end shield, or bracket, is to contain the shaft bearing and supporting the rotor assembly. It will also act as a heat transfer device for motor as well as generator. On open motors, the end frame will have slots for air to pass. On enclosed motors, the end frames will be solid because it has to withstand that temperature which will be generated in the motor. So in a closed motors, the thickness will be more to withstand or to absorb the heat. With no opening, a variety of end frames shown in the figure. Okay, like housing and end frames comes in cast iron, steel, zinc, or aluminum casting. Cast iron Is casting usually found on motors 3 HP and larger. For 3 HP and larger, we are using cast iron. The service applicable is the industrial markets where severe conditions may exist. Materials are usually about 30,000 lb per inch square. Tensile strength or the free machining. The typical sequence of operation is a two machine cell, a computer numerically controlled CNC. Okay, machines prepare the bearing bore and end frames diameters, and manual drills is used to prepare the holes for the housing attachment. Housing attachments in the sense the external wires we should connect. No, for that we are making the housings. Okay, the manual holes are used. The steel materials is usually SAE 1010 to 1020. This type of end frames may be found in all types of and size of motors. A coil is produced through a stamping process. Each part is drawn in from the stampings. This is usually progressive type die operation. A self-aligning bearing is installed. Lubricant is applied. Machine process. Zinc or aluminum end frames are found of most of motors types sizes are generally, or casting end frames are usually cast in horizontal die caster. Because of its density, zinc is usually limited to end frames for motors 3 inch in diameters or less. If the parts are small enough, more than one part is made at the one time. Okay, this depends upon the parts of the machine size. Also, motor size 1 by 4th HP. The quarter HP, a steel bearing inserts usually die cast in the part. Following the DC motors manufacturing process flow, solid steel pole pieces, frame and assembly, brush assembly, winding commutators, core and shaft assembly, complete motor, end frames. Okay, the bearing, bore and housing and diameters end of the machined. This is done on CNC lathe or special automatic machines depending on size of the machine. These are the modern trends which is used for manufacturing the motors, housing materials and the manufacturing process. Housing, so known as frames, okay, come in all types of materials and configurations. Basically the housing is nothing but that materials which is used, are made to same way both AC as DC motors. The basic purpose of housing is to cover the stator or pole pieces assembly. Okay, providing heat transfer and protection. Provide a location for mounting the end frame and serve as the attachment of the components, materials and configurations. The housing comes in cast iron, rolled, wrapped, and tube steel, and both cast and extruded tube aluminum. These are the types of housings are used for machines. Cast iron. Casting are usually found on motors of 3 HP and larger. The service application is to be industrial market where severe conditions may exist. Materials are usually about 30,000 lb per inch square. Okay, tensile strength or free machining. In most cases, the mounting feet are cast as per the housing. Steel, I mentioned steel housing with several configurations: rolled, wrapped, and tube. Aluminum, the materials is found motor, the cast iron. Okay, manufacturing process cast iron. A typical sequence of cast iron operation as a follow: machines and drill mounting, bore and inter diameter. Okay, that roll steels processed stamping process shaped platform. This piece is then formed around the materials. Wrapped steels, the manufacturing process and the same as the rolled steels except that the stator core is used as the mandrel tube. Aluminum casting. Most of the aluminum castings are produced as a complete housing with mounting feet. These are the machines like cast iron. Okay. Shaft materials. Shaft materials normally used for SAE 1045. Okay. Generally, the cold rolled sulfurized steels will cost out 50% of the more HRS and will be machines better machines. Okay. Machining options. Shear cut process. Okay. So from these options, few more options: manufacturing success, process, gauging and feedback size, completion of the process journals. Okay, some of the people believing that once the shaft is removed from the turning operations, one can use the central location of the